start recording?
Yeah, right now, just I started.
Oh, okay, perfect. So I think since we have a pretty packed agenda, we'll start. There is an Etherpad. I post the URL in the chat. Please go there and put your name and affiliation on it. That's the blue sheet. We also have a note taker. Richard volunteered, sort of. Thank you for that. Really appreciate it. If anyone else wants to correct things or so, Etherpad is a shared thing. Especially people in the discussion, go there and correct your names. Next slide. This is the note well. This is a IETF working group meeting, so it's covered by note well. Next slide. Kind of logistics. So if you're hearing us, the WebEx link is not interested anymore. The Etherpad link is there. There's a Jabber room, I think. We will use the WebEx chat for queue management. So if you want to discuss something, say something, please put a Q+, on the chat. If you want to get DQ'd, Q-. Please state your name and make sure that it's also correct in the notes, since sometimes it's hard to understand you. If you want to submit internet drafts, which you want the working group to pay attention to, put TCPM in the draft name and you'll find it. Next slide. So this is the agenda of today. We are in the working group status updates. Then we have a couple of presentations for working group documents. We have RTO considerations from Mark, 793 bis from, I think it's Michael Scharf giving the presentation. Michael Weiss will talk about RFC 2140 bis. Then we have two talks about accurate ECN, one from Bob about the draft, and one from Ilpo about the Linux implementation. And then we have a TCP rec presentation from Yuchang covering the results of the working group last call. And then we have for other presentations for non-working group items, the Yang model for TCP. We have been running a call for adaption on the mailing list, high start from Praveen, and then two things which are related to ACK handling in TCP. One is about requesting ACKs, one is about reducing the rate. These are the last two presentations. Next slide. We have two changes. I want to make sure you're aware of them. One is the MP-TCP working group has been closed, and the maintenance of these documents is happening in this working group. So the charter has been extended by the sentence which is written on the slide, which means MP-TCP maintenance is in this working group. And the responsible AD has changed. Martin is now in charge. Next slide. That's simple, no recent ROCs. Next slide. The working group documents, we have one which is in the RFC editor queue, that's the TCPM, the TCP converters draft. We have REC and RTO considerations, where we have been running a working group last call. And we also have presentations on them to see what the outcome was. We have three more working group documents, which are shown in blue, where we have presentations on it today. And then the generalized ECN, which hasn't been, there's no presentation on it, and the TCP EDO, which is even I think we don't have a current active document on that. These documents here are listed in the order of the milestones. So we are right now working from top to bottom. Regarding the ones where the working group last call hasn't ended, doesn't mean that the working group last calls show up in this particular order. We will make that dependent on the state of the document. I think that was the last slide. Is that correct?
Yep.
Okay. What I forgot is we have 3 co-chairs. Yoshi, who is running the presentations right now, Michael Scharf, who's also on the call, and myself. And I'm doing the moderation today since Michael is involved in some of the documents. Okay. Bob wants to say something.
I just wanted to ask, how would you like us to chat? On the WebEx chat or on the Jabber chat?
If there's someone on the Jabber room, then I think.
Yes, I'm on the Jabber room.
Okay, so then do the stuff on the Jabber room and use the WebEx chat for the queue management. I think this was done at the TSV WG meeting also, and I think it worked.
Yeah, I'm sort of hinting that you might want to explain to people how to do the plus queue and all that sort of thing for people who haven't done this before. Yeah.
Told them that we use the WebEx check for if you want to say something, say plus queue. If you want to go off the queue, minus queue. You can also use infix and postfix operators.
Right. It was mainly that I don't think the transcript is kept for the WebEx, so anything you want in the transcript is on the Jabber. Yeah.
Yes, that's correct. Okay, so then I'm done with that part, and it's time for Mark.
Okay. Hold on a second. Okay, Mike, I give you a ball.
Can you hear me?
Yeah, I can hear you.
Perfectly
Okay,
fine.
somebody open up slides, right?
Mark, can you share your slide?
Can I what?
Yeah, can you share your slide? You can, now you are a presenter, so you can share your slide.
Yeah, I thought Yoshi was going to do it.
Oh, okay. I see.
That's what he was hoping for and waiting on.
Oh, sorry. Then I will be a presenter, and then I will share. Okay.
Aha. There we go. Yeah, okay, so let's do this real quick. This is the old RTO consider document. You can go to the next slide. This has been around forever. I looked it up, about 9 years. So just the sort of very brief tour of what the document is. We sort of thought we understood RTOs well enough to get away from sort of the nitty-gritty specifics and move sort of more to general requirements and guidelines. And so we started that a long time ago, and you can go to the next slide. So this is a specific example of what I'm talking about. So instead of sort of an algorithm like this, a very specific equation, we can get to sort of requirements. An RTO should be based on a set of round trip times and the variance of the round trip time, things like that, okay? So you can go to the next slide. We have, I don't know, 6, 7, 8 of these big picture guidelines in the document. And my take is that we've had consensus on these for about 9 years. There's really never been much beyond sort of tweaking of these things over the whole 9 years. So go to the next slide. And the reason we haven't gotten this document done is that we've struggled with the positioning of this document in the sort of context of the rest of the RFCs that are already there. Okay, so we're trying to put some requirements, some guidelines sort of on top of an existing body of documents. This is proven to be difficult. Okay, so I would go out and try one approach and make somebody happy, and then put out a new version, and somebody else would be unhappy with that positioning. And so you see that the sort of, we have these active periods and inactive periods over the last 9 years. The sort of blue circles there, where I'm trying really hard to find some way to frame the context. It makes everybody at least roughly happy, and then the sort of red areas are where I've thrown up my hands and just decided that I don't know what the hell to do. So go to the next slide. So around IETF 106, we got a couple good reviews into about this document. So the first one I want to talk about is Corey's review, and Corey had a bunch of sort of smallish comments that were addressed, but his big about the document was that it didn't explicitly state a position relative to the other RFCs. And Corey and I exchanged a bunch of email, and we talked, and ultimately I reworked section 2 in the document, and I want to tell you how. I don't want to put words in Corey's mouth. I see him there in the list. So he can speak for himself, but I believe that these have addressed his concern. So let me go through the 3 bullets that we added. Go to the next slide. The first one explicitly says the document does not update or obsolete any existing RFC. So the RFCs that exist now, they have their own consensus, and this document does not change that. Okay. For the most part, this document is consistent with all the previous RFCs. Not to the letter, but you know, we used all of our previous knowledge to sort of arrive at these requirements and guidelines. So it's pretty consistent. But this does not change anything that's already committed to RFC. So next bullet. So this is for, the document is really meant for sort of to look to the future and provide what I think of as sort of a default for how we handle RTOs going forward. And so we say that the guidelines in the document should be used, capital should be used sort of in the future. Okay, and then we got the next slide, which is the third bullet, which says, okay, that last bullet's a should, not a must. Okay, it's fine to deviate from these requirements. If you have a good reason, that's fine. It's a default position. You can deviate, right? But if you deviate, then you must A, explain why you're deviating, and B, you have to go through the usual process and gather consensus on those deviations. And I think that's all pretty reasonable. So those are the sort of changes in response to Corey's comments. If you go to the next slide, we'll look at Jonna's comments. Again, he sent a review in around IETF 106, although he's really been sort of in my ear about this for a couple years now. And his comment is basically, why is this document centered around retransmission when it's really about loss detection? Okay, sort of find loss and sort of who cares if the action we take is to retransmit the segment, not retransmit the segment, transmit some updated information, so it's not a bit for bit retransmit. Why is the document framed about retransmissions when it really is about loss detection? And if we just framed it differently, then it would be sort of more useful. And so the latest revision centers around loss detection, talks about things in terms of loss detection. So that made the diff really ugly against the last version, because we yeah, okay. because lots of the words changed here and there from retransmission to loss detection, but the requirements and whatnot, the technical really didn't change at all. So next slide. As was noted in the opening, we've just sort of made it through working group last call. There was a minor suggestion about one of the requirements. It was a issue of just an issue of wording that will be fixed. It's not a big deal, but there were no other big comments. There were really no other comments except for that one. So next slide. So I think the chairs just wanted me to say, a few words and take any other comments that folks have here. I'm happy with the document. I think we could forward it on, but it's not my call.
So you
really
So you said that there is minor changes. So you will submit a new revision, including that?
Yeah. So the minor change, there was this sort of a little problem when I went from the retransmission language to the loss detection language. That I can't even remember who flagged it. I'm sorry. I should remember that. But there's just a little problem with that, and I will fix that and submit a version 11.
Perfect. Any other comments? Going once? Twice? Okay, then.
So what's that mean?
That means you
If
submit a new version, and
Yep.
Then I would consider it that the working group last calls have been addressed.
Great. Okay, good. Thank you.
Okay, thank you. Which means the next presentation is about RFC 793 BIS, and is Wes in the call or is Michael doing the presentation?
I don't see Wes in the list of participants.
So then I would say Michael is doing it.
Yes, that's my assumption, unless somebody masks himself as Wes. So I'd like to give a quick update on 793 BIS, basically in my role as potential document shepherd. So Wes has recently published a summary of the remaining open issues on the list. The link is on the slide, and some of the key remaining things that Wes is aware of are summarized on the slide here. So the first one is about how to handle the reserved bits in the header. Most notably whether to change the ANA allocation for that. There's room for cleaning up the registry a bit. There's been some discussion on that on the list already, so it's mostly me and Joe who have commented on that. I think so far there's been no pushback, consensus at least among me and Joe, and probably also Wes. So I assume that if nobody else speaks up, Wes will implement what has been discussed so far on the list. But of course, you feel free to look at that discussion. Please feel free to comment. As you can see at the bottom of the slide, Wes will probably still wait for some few weeks for further discussion, and then he will publish another version. The second topic that has been discussed is about a certain text on R1 and R2 values. These are thresholds. And there was, I think in the review from Corey, there was some questions on whether that's really implemented or not. I have checked that. At least I think the Linux stack does something reasonably similar to what is written in the RC. So to me, at least, this looks good. There's no need to change from my perspective, but again, maybe others should look at that. Then third topic is that gateway detection. That is about cross-layer interaction. Again, Joe has commented on that, and I think the current status is that there is no plan to change the document. And finally, there has been some discussion on, I think, the listen API call, and that's described in 793 bis. And I think Wes will implement the wording suggested by Joe unless somebody else speaks up. And that's it for the moment. So I strongly suggest to the rest of the group, please have a look at these 4 issues. If you have any thoughts on that, please speak up on the mailing list so that we can sort that out. And in general, the plan, as you've probably seen this before, that if this document doesn't get further comments, we will, of course, start thinking about the working group last call. And I see that Mirja wants to comment, so go ahead.
Yeah, I have a question. I lost the ball a little bit, but we discussed last time quite extensively to change the registration policy for the header bits. And at the time, the discussion was about how urgent that might be or not. It's not that urgent anymore, but there was also a proposal if that should be integrated into this document.
Yes, but there are 2 different things. So I think you have been, also in your document, you have suggested that it makes sense to clean up the registry. First of all, because the header bits are documented on a separate page, first of all, and then some of the reserved header bits don't have even an entry. And at the moment, the proposal is in 793 bis to basically clean up the registry, to move everything to one page and to the reserved bits that are at the moment not in the table. The allocation policy will not be changed by 793 bis. So that is probably entirely out of scope of 793 bis because it would require a separate proposed standard with community consensus on changing the allocation policy. So this is only about basically editorial changes to the IANA registry. It doesn't change anything regarding how to allocate bits or things like that, because that would most likely have to be discussed separately in a separate proposed standard document. In general, 793 bis only reflects changes to TCP that are already documented on standards track.
I mean, I think that's, I'm okay with that, but I think that's a decision for the group to make. I mean, like, if we have this document, we can decide to change everything if it's reasonable, right? So we could have a discussion if we want to do the update of the policy within this document or in a separate document. For me, both is okay. I just wanted to check what the group wants.
Well, I mean, I agree it's a valid discussion to have. From my perspective, also as chair, the scope of this document has been very clear from the beginning. The document only implements changes on standards track. So we can, of course, change that, but changing this, that would first be a scope of the document. And I would personally just suggest not to go down that road, but of course, we can have this discussion. But as I said, what is at the moment, I think, agreed between everyone who has commented is that we will clean up the INI registry because there have been, it's not perfect. The current status is not perfect. We will move one table, create a new table and move it to the other TCP parameter. So that's the suggestion at the moment. But as I said, I mean, this is open for discussion. It hasn't received a lot of feedback. Every 4 points could deserve further feedback on the list. So please feel free to continue the discussion on the mailing list if you have any thoughts on these 4 points.
Okay, thank you. I think at least cleaning up the registry is very, very good. So I can go ahead and update my document, take this out, and then bring it back to the group. Yes,
so I think that is, I mean, I think there has been a discussion before on cleaning up the registry. So I recall that it has been discussed on the list before. So there seems to be consensus that that's a good thing to do. And that's just editorial. It doesn't change anything from a standard perspective. So the proposal is to do that in 793 bis. And if we want to change the allocation policy, I mean, that is probably a separate discussion. At least I would just suggest to keep that out of 793 bis for the moment.
Okay.
Any other questions? If that's not the case, then thank you very much, Michael. And we are going to RFC 2140 bis, which is also Michael Welzel in this case. You have 5 minutes.
Oh, okay, yeah. Well, 5 minutes, one title slide and one more slide. The title slide,
including the discussion.
Yeah. So that's how we look. Yes. Well, can you go to the next, please? All right. So what really happened is that we had this version 1, which didn't get much feedback, but then at some point got a pretty long and very thorough review from Michael Schaaf that we incorporated. It took us some time, but we incorporated it all and answered everything. It was extremely helpful. There was it was just about texting, so there wasn't any real technical issue as far as I remember that would have been a problem, but some reorganization necessary, some stuff making the text just more readable and easier to understand. So that's the reorganization and more clear discussion that you see mentioned on the slide here. Section 6.3 is new. There is more text explaining things a bit better. There is quite a bit of reformatting. Tables have been moved around, and typos have been corrected. Security considerations now talk about fingerprinting. There is Appendix B that mentions all the TCP options in the world and talks about whether you would like to share them or not, or like share something, cache something about them or not. And that was originally meant just for us as something to remember and look at, but we decided that this could actually stay. So we rephrased things a little bit to be a bit more formal in style. The references were reorganized, and that's it. It would be great if people would read it, and it would be even greater if we could move on with that document to whatever the chairs think is appropriate. That's it from my side.
Thank you very much. Questions, comments, suggestions? So then, if I understand that right, Mirja wants to say something. I know, that's an old Q+. So if I understand the authors correctly, you are done with the document.
Yes.
Okay. So then this is a candidate for a working group last call from your perspective.
Yes.
Okay. So then the chair.
Maybe I should add, I tried to get at least one review for this document, and we have a reviewer who has committed to review it, but he hasn't done so far. So I will ping him again. I've tried it already more than once, but I hope that we will get another review relatively soon, so that we have at least one other review. But of course, if that doesn't work out, we have to start thinking about moving to a working group last call. Anyhow.
Yeah, so I think that pretty much describes this situation from the chair's perspective. If we can get another review soon, we would like to have it. If not, then this is a candidate for a working group last call. Okay, if there are no comments, no questions, then thank you very much, Michael. And we go forward with Bob on accurate ECM feedback. Bob, you have 15 minutes, including discussion.
Yep.
And people on this call, please go to the blue sheet. Put your name on the blue sheet. It's on the Etherpad.
Yep. And I'm expecting you to put the slides up. Yep. Okay. There's the draft name, and I'm going to cover 2 drafts since the last update I gave on this, which was November last year. So next slide. Right, just a very quick recap. Accurate ECN is a way to get more than one congestion signal per round trip time out of the TCP wire protocol. To change the wire protocol, because the previous way of doing it essentially turned a toggle on, which stayed on for the whole round trip time, and so you could only get one per round trip time. And it involved before two flags in the TCP header. Next slide. We're moving to 3 flags that are used for the original negotiation at the start during the handshake, but then they get overloaded as a 3-bit counter, and there's also accurate ECN option. Next. And the accurate ECN option, I should add, is supplementary information which is not essential for the working of the protocol, but you don't get the full accuracy without it. Right. A brief update on the activity since November. From draft 9 to 10, there was a large number of what we might call minor technical changes, tweaks, etc. Large amount of them due to Ilpo's implementation, which he's going to present straight after this, so I'm not going to dwell too much on some of those things other than give a bit of introductory and high-level overview to help people orient. And huge thanks to Ilpo, whose implementation, I should say, was based on Olivier's and Mia's, for going into it in such depth. It's been a great help. And the draft is now much improved because of that. And there's also quite a bit from other list discussions that you'll notice. Those 6 main areas are the headings of the next 6 slides, so I'm not going to list those here verbally. And then from draft 10 to 11, there was a change from experimental track to standards track, and I tried to separate out those 2 changes so that it was absolutely obvious which deltas were which. Thanks. Next slide. So the first of those technical points, number 1 of 6, when I was doing the looking at making this into a update to 3168 as a standards track document instead of an experimental, I went through the whole of 3168 and checked that it would cover everything and be a sort of first-class replacement, and realized that there was one section of 3168 that wasn't covered, which was essentially your rights and obligations about using ECN once you've negotiated accurate ECN rather than the original 3168 feedback mode. And I'm not going to list all these, talk about all these things here because they're all motherhood and apple pie. They're basically saying you can set ECT, but you don't have to. You have to respond to congestion, blah, blah, blah. But they're all in the draft. Please go review them. This is just a heads up that they are all there. Next. Right. I want to go into this one in a bit more depth. The backwards compatibility negotiation that's done during the handshake has been in accurate ECN since right at the start. It's very similar to the one in 3168, which, if you like, was backwards compatible with not having ECN, and there's now sort of 3 levels, which you can see in this little diagram on the right-hand side, where if you're an accurate ECN client, you offer accurate ECN, and whatever sort of server you hit will either accept accurate ECN, or if it's a 3168 server, it will give you accept ECN back, and if it's neither, it will give you non-ECN back. And there's so essentially you get the highest version that both ends can support in one round, an obvious sort of capability negotiation. Now, if for some reason your packets aren't getting through, there is a recommendation to keep trying once more and then fall back to asking for not ECN. And the little red brackets in the diagram, the little red parentheses, and the strike through at the bottom of the little diagram are pointed out in the bullets. Essentially, the parentheses say that the server doesn't actually have to implement 3168 ECN because that's not necessary for the negotiation. Obviously, it's up to the implementer whether they do, and there's no particular reason why they shouldn't, but they don't have to. The crossed out or ECN on the sort of fallback at the bottom there says that if you fall back from asking for accurate ECN because you're not getting through for some reason, maybe the bits in the header get blocked by a middle box or something like that, then you can fall back to not having ECN at all, but you can't fall back from accurate ECN to just ECN. And this is the same in the other direction for the SYNAC. If you've already said you can do accurate ECN, you can only fall back to no ECN at all. And this is just because otherwise the number of possible combinations of SYNs and SYNs that are asking for different things that may get reordered and some may get lost, mean the number of possible combinations of states you may be in gets ridiculous. So it's just easier to keep it to 2 for the small number of times where this might happen. So I'd appreciate people reviewing whether they believe that is a good decision. I mean, we could make it even more complicated, but I don't want to. So that's essentially what that bullet says there. The first 2 bullets say. Then the third main bullet says that when you do retransmit your SYN and fall back to non-ECN, you should use the same ISN, and this is to prevent a downgrade attack where someone else could copy your ISN and get in, or sorry, someone else could just generate a random ISN, and this allows the other end to notice that it's not the same ISN, and therefore kick them out. And finally, there was just a point in the text where we still we're talking about the nonce, and we've now reserved that rather than it being for the nonce because the nonce is now historic. So that's that one. Next. Right. So the next one is going to be covered a lot by Ilpo in Ilpo's talk, so I just want to give some background to that. And essentially, this is the background slide to my next slide, where mangling detection is done only on the handshake. So the only time one end gets to see a reflection of what they sent is in the 3-way handshake. And I've tried to draw it with a little red and yellow colors on the diagram on the left, where the ECN field that's sent by the client in the IP header gets reflected back in the SYNAC in the TCP header, and similarly the IP ECN field that's sent in the SYNAC under the SYNAC gets reflected back in the TCP header of the ACK, right? So and the 2 tables taken from the draft show the same encoding is used to encode the 4 states of the ECN field in the TCP header to give that feedback. So next slide. So that's how the protocol is meant to work, and we've just tweaked some of those things. Firstly, the first bullet says that you only reflect the IP ECN field of the SYNAC on the ACK of the SYNAC, whereas before in draft 8 and before, we said you also repeated it in the first data packet. And Ilpo will talk about this, but it got really complicated to define what the first data packet was and whether there was one, and there was all sorts of problems with dupacks and things. Then the second point here is that the reason we were trying to repeat that field was because the third ACK is not reliably delivered. So we weren't not getting reliable delivery of this mangling detection. Now, having removed that, we no longer have reliable delivery of mangling detection, but what we have done is made sure we at least get reliable delivery of the congestion notification. So if there's CE on the SYNAC, we get reliable delivery of that because of the arrangement for showing that in the counter of CEs that start coming on the data afterwards. So it does get through on the packets after the ACK, but again, I'd like people to comment or review the decision not to have full mangling detection if that ACK gets lost. So then you would not, or the server would not know whether its IP ECN field was getting mangled on those connections where the ACK gets lost in the other direction.
Yeah, can I interrupt you for 1 second?
Yep.
So it would not know if it doesn't have the option, right? If it does have the option, it can still detect.
Yes. Yeah. Yeah. And there are a number of other things you can do. One of which I've actually it was advised by a couple of people. I know Apple do this, where if they're getting CE continually, they turn off ECN on the basis that it's probably mangling. And I can put a recommendation to do that in the draft as well. I would like to. Right. And the third point I will leave for Ilpo to talk about because he's probably got more time than me to do it. Next. Right. So the third area where there was a minor change, we have this 3-bit field I mentioned as a counter of the number of ECN marks arriving at the data receiver that it feeds back to the data sender. And of course, with only 3 bits, that wraps quite frequently. It can do. And we had a statement in the draft that it should conservatively assume that it wrapped more than once if it could have done based on the ACK number. So if the ACK number looks like you could have had enough ACKs for that to counter to wrap, and maybe they've all got thinned out or lost. Previously, it had to assume that the field did wrap, but that ended up giving really quite poor performance in quite a lot of cases, assuming that you'd got 9 CE marks instead of 1. And so we've changed that text to the safest likely case, which is a bit sort of undefined way of saying do your best, whereas conservative was just too poor. And there's an example algorithm of how to do that in the appendix, which works reasonably well. Next. So now moving on to the optional accurate ECN option. In the last working group discussions, they'll be introduced this idea of, I think originally it was Neil Cardwell asked if we could make the order of the fields a bit more optimal for certain cases. So we introduced 2 possible orders for the fields and a way of indicating on the first occurrence of those fields which order you were using. There was general consensus on that, but then Michael strongly disagreed with it on the list. So I haven't changed it yet, but I'm quite open to changing it. And there are 2 alternatives, one being using 2 option kinds, which Michael has pointed out is not a sparse or is not a scarce resource. And the other option would be to add a flags byte, which Ilpo is proposing. I'm not overly in agreement with that solution, partly because I don't think the field that is in the flags byte at the moment is necessary, and so then we'd have a flags byte that only did one thing, and we could do that with 2 option kinds. But if we do have a flags byte, if other people disagree with me, then I would certainly agree with putting the field order into that. But of course, we have very limited space in TCP options, so any individual byte is something we have to be very careful about. Right, and we have added more robustness in the rules concerning when you send an accurate ECN option. And I'm not sure Ilpo goes through this. Perhaps Ilpo can interject if he is going to say all this, then I don't need to go down this list. But
you have 2 minutes, including discussion.
Okay, I'll jump over it, assuming Ilpo can talk about this. Next. Right. Just a corner case, things like in-window SYN during time wait. Ilpo found all those things when he was doing his testing. Next. So we've done some editorial changes, rationalized the structure, because this draft has been going on for quite a long time, so it's got in somewhat of a mess. And Ilpo pointed out that some of the main sort of extremely obvious behaviors didn't actually have any normative text, so we added that, and added some text about what acceptable packets were and made that all explicit. Next. And the other stuff there is not important editorial stuff. So now this is the switch from draft 10 to draft 11, which was from experimental to standards track. There's just one slide on this. So we caught all mentions of experiment throughout the draft and made it not talk about experiments, removed the experimental goals section, and added a complete new section giving all the updates to RFC 3168, which were quite organized in that, this table here shows the mapping from one to the other. You've got a whole section or subsection in 3168 on TCP initialization, which maps directly to negotiating the use of accurate ECN. You've got a whole section on the TCP sender in 3168, which we don't change hardly because this is about feedback. It's mainly about the receiver end, except obviously where it talks about responding to responding to ECE, we talk about, or accurate ECN talks about responding to counters instead, and the sender no longer sets CWR to say it's reduced its congestion window. So then the TCP receiver was where all the changes are, and that maps to section 3.2 of the accurate ECN draft, which is the huge section in the accurate ECN draft that talks about all the ways that feedback's done, and it's 3.2 has got subsections, so it's a very big section. 615, there was a little bit about acceptable retransmission packets and how to test for them in 3168, and we, as I just mentioned, have now included acceptable packet tests, or more explicitly in accurate ECN for all packets, not just retransmissions. And finally, there are a number of sections that prohibit the use of ECT on control packets and retransmissions. Now, the accurate ECN draft doesn't change any of that. It doesn't change any of those requirements, but what it does do is define the feedback if you get one of those packets anyway. And that allows things to change in future, and it should have been in 3160 anyway to say, even though we're saying don't do this, if you get a packet like this, what do you do? Should have been in there. And it's now in, well, it's been in accurate ECN for a long time. Okay, but there's the mapping there. Next, I think we're on the last slide. Oh no, there's one more question, yes. The mangling detection, there was a question that you may want to consider, that if it becomes a non-problem longer term, there is a bit of complexity in accurate ECN dealing with mangling and detection. And we did think, how could we remove all that in the future? It wouldn't actually be at all easy. It would require quite a long, drawn-out two-stage process, but you can read this slide if you want to think about that. And finally, the last slide. just to say, ILPO's full implementation in Linux is a patch in 28 sequence parts. He's submitted it for upstreaming as a request for comments, and it's on hold pending the EC1 decision in the Linux community as well as in the IETF at the moment. And it's also Accurate ECN has also been implemented without the TCP option in FreeBSD, but the Linux one is the full spec. It's every little piece of it. And as I've said, we're ready for working group last call, but I think the chairs want to wait for the ECT1 decision from TSVWG before they do, even though Accurate ECN theoretically is independent of that, but I think I can understand why they want to wait. And similarly, generalized ECN is dependent on Accurate ECN. It's a normative reference, so that will have to sit in the same holding stack.
Thanks, Paul. Please be sure to the question. I think Mirja was first.
Yeah, hi, thank you for all the work you did. You did most of the work here. Looking at this text again, I have two minor points. One is about the ECN or ACE rep behavior. And I realized that there can also be a case where the counter actually doesn't change, but you have received enough X that it could have repped once, but to exactly the same value again, right? Mm-hmm. And then in this case, if you assume it didn't rep, then you didn't get any congestion notification. So we might want to be more careful about the wording here.
Yeah, I think it says if it wraps more than once, or it talks about whether it wrapped more than once.
Yeah, so I mean, I think the important point here is to be conservative about the point that you get a congestion notification and be less conservative about how many markings you had in case that is an input to your congestion controller. So maybe we can distinguish that and word this clearly.
Okay.
I think it's a minor point.
Okay, maybe you can stick something on the list about that, so that I've made a note of it, but that will make me remember, and also it will make me understand what you're talking about.
Yep, comment that on the mailing list, please. Michael, as an individual.
I had another
point. Oh, okay. Sorry.
And then about the update section, right? I didn't realize that much that it actually says everywhere we update this section with this section, we update this section with this section, because I actually don't think we update the classic ECN mechanism. We just add something on top of it, right?
No, it's everything in those sections is replaced. In 3168, it's completely not relevant anymore. It's not added, okay. It's replaced.
Okay, I wasn't aware of that. I have to double check that. Okay, thank you.
Yeah, please do double check. Yeah.
We are running over time, so Michael, please be sure.
Yeah, only a quick comment on slide 10. So it's correct. I would agree to 2 option code points. I've also offered other solutions than the ones that you have on the list. For example, you could use the length as another differentiator, or you could just add a bit in the beginning to make the first bit sticky. There are tons of solutions how to sort this out. The easiest one is probably the 2 option code points, and that would work well for me. But
yeah,
there are more solutions to this.
I admit I filtered out the length one because I knew that Mia would originally didn't like that one. Maybe Mia can say something about this because it sort of means you can have variable size fields and things like that. And go on, Mia. You originally didn't like having different length to mean different.
Yeah, are we? So like, I have to remember. But aren't we already have different lengths, because you can always leave out some of the fields if you don't need them, right? So this is already kind of used.
Yeah, no, this was using the length field to determine the order of the fields. I don't quite know how it was going to be done, but
we don't have the time to discuss this now.
No.
Not the right time to do it. As I just said, I mean, there are more solutions to the problem, but the easiest one might be number 1.
Please put that on the mailing list.
Yeah, and anyway, I wanted to leave that until Ilpo's talk, because he's going to talk about his flags byte anyway, and if we decide to do that, there's another way of doing it.
Martin.
Yes, can someone briefly explain why we need to hold this for ECT1, the decision in TSVWG?
We just want to be on the safe side. That was, I mean, we have no particular reason. We just, so when we discussed this, we discussed this before TSV, and we were hoping things get cleaned up. So we are still hoping that things get cleaned up soon. If that doesn't work out, we need to reconsider. But that was the hope.
Well,
I'm pushing some quick resolution on that in TSVWG, but okay.
That's perfect.
Hopefully this won't matter. That's it. Thanks.
So
Okay.
I do have a question to come back on that, and in that, you know, if that goes on and on in TSVWG, I would like this to not hang on it, because it's just what happens otherwise is then the chairs say, well, no one's interested in this one anymore. It's been sitting around for 2 years and no one's talked about it, and that's because we're all waiting for something, you know.
Can I reply as well? So
the point is we are 10 minutes over now. So it's like I have to, Ilpo has to then speed up a bit or something else. Yeah. Mirja?
yes, so just I think there is no dependency from accurate ECN to alpha-S, but only the other way around. So I don't think we have to hold it up. The only tiny little design decision that might depend is like exactly what we're looking at right now, the order of the values in the option. But if we have a flexible option here, how to handle it, I don't see any dependency.
Yeah. So the position was, assuming that this cleans up soon, we would like to wait just to be on the safe side.
Yes.
If this doesn't work out, we will reconsider. So the plan is not to hold this up for a large amount of time if the other stuff doesn't work out.
That's totally fine for me. I'm just saying that I don't think there's a technical dependency.
Yeah, it's fine for me too.
Gori?
Gary here as TSVWG chair. As soon as this is finished, run those updates through TSVWG. I don't think the dependencies are enough to hold the document.
Okay.
Okay.
So then, thank you. We are 10 minutes over time. Ilpo. Any minute you can give us back is perfect.
Yeah. One additional thing why I had not wanted to put this yet to upstream is that if we make some wire format change, then for example related to this option kind, then that's of course problematic if there's some pre-existing deployment with something else. So that's another thing. Yeah. So I'm going to talk about this. The accurate ECN Linux implementation. So if you go to the next slide. Yeah, so this is built on top of the earlier work, like Bob said, and initially I started working with this when there was this 07, not 07, 09 draft available, and as far as I know, this is the first implementation which actually includes the support for accurate ECN option. And I discovered some technical challenges, but none seem to sort of make the whole approach non-workable. So in that sense, we are good to go with the minor tweaks we have been doing. And the feedback from the implementation is adopted into draft version 10, or mostly it was adopted in that, so there are a large set of changes. And in addition to the implementation, I have also created this unit test suite. There are some URLs for those. Yeah, so next slide, please. So first I'm going to talk about this handshake reflector thing, so I give it background so that you might be on the might even understand the understand what is said on the next slide. So Bob already covered some of this. So during the handshake, we will feedback the ECN field of the opposite side, and or the opposite handshake packet. So and in the 09 SYNAC ECN code point was encoded to third ACK of the three-way handshake, and also of the first data segment. So these create additional problems because the SYN bit is off, and the reliable data channel was provided using this first data segment, and it was to because we, in that case, we would have wanted to avoid the AC field ambiguity, so that there is no different implementations. All similar segments will also need to use the same encoding, and some made it just a warning that we made also changes to this in the draft version 10. So next slide, please. And so first of all, there are these challenges related to retransmissions in general. So Bob partially covered this in his talk also. So when the ECN code point of the original and retransmit are differing, there are some scenarios that need to be handled, which the draft did not address. And since the end that is sending the packet does not know what the other end sees, so this initialization needs to consider the cases such that it is safe, and also the behavior on C marking must consider the case where the only one of those copies of the SYNAC, for example, has this marking. Of course, it's not yet. It's in the ECN++ if we enable those, but this draft should already handle those cases. And then we come to this case where the SYN bit is off. So they were quite problematic. So first of all, both the TX and RX side required additional state. Well, it was doable, but it was quite complicated to look into all these sequence numbers, and it requires checking on in the established state. You need to do these additional checks for every packet, whether it's now the time to use the reflector or not, since it's overloading the same bits. And because of this overloading, there are some masking problems. And if only single sequence number is used by this, or make this reflector decision, it actually disables the accuracy and for the whole half connection when using a unidirectional flow, since the sequence number of the other direction does not advance at all. So you are sending all the time the reflector, so no accurate ECN at all. And then relatively small problem was related to segmentation offloading. So since the reflector will have different header than the remaining or the other segments after it, it's not possible to send them as a single chunk downwards. And then the major problem was related to TCP fast open. So with fast open, it can be so that there are no third ACK or the first data segment in a similar sense as we have for the non-fast open case. So and if we consider this first bullet, so when there are retransmissions, it's hard, or actually it's impossible for the other end to know what the other end is actually seeing. So they cannot really agree what is the first sequence number or the first packet at all, because they might have seen different things than. And then of course there is also this delayed arrival of the reflected value. So it somehow limits what decisions can be made based on it. So next slide, please. And we had different or discussed different solutions to this, and tried to use both sequence numbers, and also discussed about using option for this, but those were ruled out. So we simply made the approach less complex, and it of course has some downsides. So it makes the signaling unreliable, but it's still relatively simple. So, and the good thing is that if we put it only to the reflector only to the third arc, we can use the existing state transition and trigger. So when we get Synac, we do one thing, and when we move to the SW state, that's other transition that is interesting to us. And it means that we occasionally lose the mangling direction, but that feature is not, loss of that feature is not catastrophic. The more problematic case is, of course, that it creates ambiguity. So there can be similar arcs later in the connection. So which look exactly like the that first bucket. So it might be possible that one ends up misinterpreting the ACE field in some cases, but again, it doesn't seem catastrophic. So the connection does not die because of that. And this approach was adopted in the draft version 10. So next slide, please. And then the segmentation offloading had some has some cases it's good to bring up here. So the CWR flag handling differs from that of the 3168, and the segmentation offloading for that clears the CWR flag after the first segment. So when you put large segment or give it to the signal offloading hardware, which it takes the CWR or sets the CWR only for the first segment. And another thing that should be considered, that the offloading does not hide the changes in the ACE field. And I made the required changes for the software-based offloading case, so this GSO or GRO, and on the receive path, the CWR was used to sort of flush the pending block of segments, and the accurate ECN might have long runs of segments where this CWR flag is set. So it of course would negatively affect the performance of accurate ECN if the offloading ends up flushing after every segment. And then some thoughts about the hardware offloading. I didn't actually test with any hardware offloading, but went deep enough that I think I understand the problem space. So to allow the hardware offloading, there is flag added to the SKB such that it can indicate that accurate ECN processing is required, which is actually do nothing sort of, but because there is this existing CWR clearing thing, we need to be prepared to that. So if the hardware would clear the flag on its own, it would of course corrupt the ACE field, and it's not clear if the hardware which supports this CWR clearing can be made such that it is not or it can be disabled so that it doesn't do it. yeah, so the next slide, please. And then about the accuracy option. So the accuracy option carries this least significant bytes of the usually larger counters. So the draft says that they are probably 22 bits or more, and I have 22-bit fields, not 20 but 32-bit fields for these counters, and they sum the payload bytes you receive for particular ECN code points. And since the accuracy option is not always sent by the receiver, the draft only gives the minimum rules when the option should be sent. The implementations must or are expected to estimate. It's not mandatory, but are expected to sort of estimate the counters while there is ACKs coming in which don't have the accuracy option, and this requires heuristic to decide which counter is going to be increased when you get an ACK without the option. Next slide, please. So to support this heuristic, there is this change triggered ACKs. The draft says that when the ECN code point changes on the receiver side, you should send with this accurate ECN option. And the problem with that is that since the code point change, you are actually increasing the new counter while you on the earlier ACKs you increase the other ones. I realized I might actually have a problem in this figure now, which I have not noticed. We would need to add some ACK without option between the data 11 and 12. No problem. So the receivers, when it's sending this option, it actually has changed both the ECT1 byte counter and the C byte counter. So the sending side does not know which of these counters is the one it should increase when it gets next time the ACK without the option. So after this data 13th data bucket, and this is problem with any of the edges. So one could build some heuristic, but it gets easily lost even if you lose one data or one ACK bucket. It then reverses to the wrong counter on every change triggered ACK. And to solve this, the change was made to the draft so that the option is now required for the change triggered ACK and the next ACK you send after that. So in that later ACK, it's unambiguous which of the fields actually is increasing. Yeah.
May I just interrupt, Ilpo?
Yeah.
You said it's required. It's still a should.
Yeah.
And all these are shoulds. And I just wanted to give the context for this, that if you did all the shoulds, then you wouldn't have this problem anyway, because you'd be having accurate ECN options on most packets. And this is only when you're really trying to be sparse about which packets you put accurate ECN options on, probably because you've got lots of other options and you're trying to be careful about how much space you use.
Yeah. So on the next slide, I actually have now this proposal. So how this heuristic could be avoided. So if you put the next slide. Yeah, so instead of using some heuristic to decide what the receiver is going to increase next, it could be included to the accurate ECN option. So if we add this counter 2-bit field into the option itself, it's possible to use that value to increase the correct counter on the next stack. So you only need to get one option through, and then the sender immediately knows what the receiver is going to do next. This, of course, would create other possibilities. So there are these extra bits remaining in the one octet that needs to be added if this is chosen, and this same field could be used, for example, for the field ordering, and there are other possibilities, so that if there are no byte counters included, if there is no A clauses, then also the count itself could be used to do the byte counter switch. So if there are any comments on this, I would like to hear your opinions. Yeah,
we come to an end for the presentation, then we have time for a question.
Yeah, so next slide. Yeah, so and then I was looking to this draft, and in the appendix there are a lot of algorithms which sort of might help to implement the option related things, and under some circumstances one might when there is A clauses, the estimation might actually result in increasing the wrong counter, and that needs to be corrected downwards when the option next time comes in, and the draft or I think it still has some problems in this, so that it's using this unsigned modulo, which is problematic because it cannot correct downwards, and there are two ways to solve this. Either use signed delta, so that the counter can also decrease, or alternatively one would need to duplicate all the counters on the sender side, which seems somewhat wasteful. And another problem related to this relatively small field, so only 24 bits, is that it cycles relatively soon. So the draft must ensure that, or should ensure that the counters do not overflow. So the option must be included every now and then to handle that case. So next slide, please. And then there is this heuristic in the appendix. There's algorithm which uses this delta for the CEB. So this byte counter delta is used to rule out the ACE overflows, and in order to run that algorithm, one actually needs to have this delta available. So it seems good from robustness point of view that every time the ACE field is changed also to include the option so that the CEB delta can be calculated from numbers that are up to date. It's not absolutely required, but still seems good defense in that like approach. Yeah, next slide, please. Okay, so I didn't have more. If you want, we can take a look on this box slide. I don't have it.
We don't have any. We are running over time, so
okay, yeah.
Sorry about that. Any comments? Yoshi.
So about TCP option, do we need 24 bits for counting bits? And maybe if we can squeeze to 22 bits, we can create some rooms.
Yeah, I suppose it would be possible to also decrease the size of the fields. It only means that the option needs to be sent more frequently, and of course, if there would be long loss of access, then some problems might happen, but not very likely, I think.
Can I just come back on that, Yoshi?
You have 1 minute.
Yeah, the ACE field is just 3 bits, and that doesn't use byte counting at all. And the algorithm is designed to work with just that. The byte counters are there if you have space for them, and so sort of reducing them to be less accurate seems to be a bit of a sort of halfway house that maybe is a bit too complicated. Given you're only using them when you've got space for them anyway.
I'm closing the line after Mirja. 30 seconds. Mirja?
I should unmute them. So the question about the option. I'm not sure I actually still fully understand the problem, because at least if the CE counter increases in the option, it should also the ACE field should increase. So you should be able to distinguish those cases, which is the most common case, right? So I'm not sure if the problem is as big as you describe it. And then if we need a solution, I think the solution is fine to send basically 3 more X with options as you have proposed. I don't think we need a separate field for that in the option. But maybe to phrase the question, did you look at this case that you can use the ACE field to distinguish better which counter has been increased?
Yeah, well, it's possible to use that, but then it means that you only can use two of the ECN code points to really run this kind of heuristic. And another thing is that there is this cross-checking between these fields. So on the if we base some checking on the other and then the other way around, it of course creates this nasty loop of checks. So I suppose it might be possible to use it, but there are these caveats. And
yeah, I think we should look into that, and also to the point that you cannot distinguish ETC1 and ETC0. So I just want to state again that I think the requirements or the base design guides we had at the beginning was that we want to make sure we don't lose the congestion signal. So we don't want to run into the case where you got a CE and you don't get the information that it was there and you cannot react to it. So that's why we have the CE in the header, and that's why it's important to always have the accurate information about the CE. And the other thing we discussed very intensively at the beginning is that we don't want as a requirement to also check the order of the different markings or to provide the order. If that's a side effect, if you can get it, that's fine, but it wasn't a requirement.
Okay, please discuss this further on the mailing list. From the church perspective, we very much appreciate this implementation effort in reporting about the experiences. We think this improves the implementation, not the implementation, but the standard and the draft.
Both the implementation and the draft. Thanks a lot for that. Yes, +1.
So thank you very much. We are still over time. The next is June reporting about the results of the REC working group last call.
Hi, I'm here to present the RAC draft, especially to our plan to address the working group last call comments. Next slide, please. So basically, there are three things that we need to address, three categories. One is some bugs in the pseudocode, and the other is some protocol changes in order to enhance it based on the comments. And the last one are a lot of writing suggestions. There needs to be a major surgery on writing. So they dive in the first one. The first one is the bug that Elpo found that the loss retransmit is unclear how that would actually work in, from the pseudocode. And there is a small bug in the pseudocode that we need to define that when you are sending or resending a packet, you need to mark the packet lost. That's false. Again, you need to reset that mark. So that's the bug, which we will correct that in the next iteration, and then we will put more words on how loss retransmit detection will work more, because it was a bit vague. Next slide, please. The next one is a comment from Teresa that it's not clear how RAC can apply in the RTO recovery, because the text suggests that mainly this is a change to the TCP class recovery, but that's actually not the case. RAC is for both class recovery and RTO recovery, so we're going to put more text. So here is the very simple, intuitive example, like why RAC even matter in RTO recovery, because supposedly it's just a timer fires, and then you mark the first packet lost, right? And then you retransmit that. Why would RAC even matter? So let's have a example. Let's say at time t0, you send one packet, and the RTO is 1 second. So you put a 1 second timer on. Then at 999 milliseconds, you send another one. Or maybe you send another 10 because so you total send 11 packets. 1 millisecond later, the RTO timer fires, and then he says, you know what, all the packets that's pending are lost. So this is clearly unlikely because you just send the last 10 packets, right? So if you think of why that's unlikely, because you look at the transmit time of this packet. And many TCP stacks that we know didn't have this kind of check before. This is essentially the same principle as RAC, right? You want to look at the most recent transmission time and now, so you can judge whether the packet is likely lost or not. And then you can put some reordering window allowance. So that's the change that RAC would recommend you apply for the TCP recovery. And essentially, the pseudocode is very similar, which we put it here, but it will share a lot of commonality with the main RAC code. So we'll break that into some subsystems. And this is also what's implemented in Linux as well. And we have found that this actually reduces a lot of unnecessary retransmission during RTO. So that's what we are going to put in the new RAC iteration, revision. Next slide, please. The other thing that many people recommend is that we should really make the reordering timer a should instead of a may, because it actually improves performance. And we are going to change that because we agree with those comments. And to recap, a reordering timer is to say, all right, this packet is not there to mark as lost because we're still waiting for the reordering timer to expire. But of course, if there's no further active event, then we will have to wait for RTO, and that's so RAC recommends installing this reordering timer when the reordering window expires, and it does help improving the performance, especially in the application limited cases. Another comment that's suggested by Alpo, again, is that it's unclear how long should we wait for this timer. So for example, you have 10 packets, right? And the very first one, the reloading timer will expire in 1 millisecond, and the last one will expire after 1 millisecond or the 5 millisecond. The idea is to put it on the 5 millisecond so that when the timer expires, many packets will be marked as lost with confidence. It's more conservative, and we like this approach because even though you may fast retransmit a little bit slower because you set a timer that's more conservative, but since rack is about dealing with reordering, we feel a more conservative timer may be slightly loose on the performance optimization. It's still a good trade-off. So next slide, please. So now comes to the right, that's the most people's suggestions. Needs a lot of major surgery. The biggest one, which we agree, that the current TLP part of the draft writes more like an add-on, an appendix. It's like you glued the draft onto it. So we are going to definitely rewrite a lot of part of it, including mention that in the actual abstract introduction and overview and the design rationale. The next comment is about the overview is too terse, in that it's too simplified. We really should explain rack and TLP protocol in more detail instead of like 4 sentences. So that's what we are going to extend to. And also, I think Martin suggested a table of content, and yeah, because the draft is already very long. We are going to remove the experiment and performance evaluation. I think it serves the purpose when it was an experimental draft, but now it's a post-standard draft. So probably don't need that. But if you actually feel strong that we should keep it there, I'm happy to discuss on the list. Well, and just as a side, we are going to reply every reviewer's email separately as well. But right now we're just going through all of them and make sure that, you know, if we're going to change one thing that would please 3 reviewers that have opinion on the same part of it. All right, next slide, please. A lot of clarification questions. I think the most important one is we, the author, all the 4 authors, have no intention to encourage more network reordering, with or without rack. So the text definitely needs to clarify that, because we use some word things that would make it sound like, hey, we want to have rack, so network can reorder things to hell. No, that's absolutely not our intention. Our intention is to say, look, we have found reordering exists, and we want to make TCP more robust to it. But by no means we want to encourage more reordering, because reordering by any time is really not going to do well for the performance on the receiver side, particularly. So we will be more explicit on that. The other is people are kind of confused reading through the text. So what's the dependency between TLP, rack, stack, DStack, limited transmit? It's like all over the place. So here's the rack requires stack, TLP requires rack. When I say TLP requires rack, it is possible to implement TLP without rack. That comes with a lot more ambiguity and a lot more complexity, because that's what we did in Linux before. And then we decided to get rid of that part because it just doesn't worth that complexity in the stack to deal with a kind of like outdated stack that doesn't support stack. So another one is about DStack and limited transmit. They are both recommended, but if the stack do not support that, it's okay too. Also, more clarity about how rack and TCP segment offloading should handle. For example, a TCP segment offloading would bunch many packets into one sort of jumbo frame. So how do we handle that? Needs more clarity. So we will do that. Also, like how the reordering timer. We talked about how we set up it, but how do we cancel those timers? So these are also important detail we need to add. And then the last thing is the rack reordering window. We say initially started with a quarter of RTT, but if no reordering is detected, it's now reduced to 0. And then how does that really work with that? Oh, we can also use super stretch, and the text is just not clear how all this interacts. So we are going to clean that up too. And make sure we clarify like how rack uses or implement the super stretch code heuristic. Next slide, please. Last one is there are a lot of wording that sounds like unsubstantiated. Meaning that we will say, okay, for example, we'll say, oh, all this loss recovery techniques before don't work, without citing any scientific studies, right? Or things that is like, oh, there's a prevalence of loss retransmission. There are a lot of ordering, blah 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 is common. All that we will remove and make sure that we don't sort of talk this kind of things without data. If anything, we'll say ROC is to deal with reordering, right? And on some networks, the reordering can be very prevalent. And there are also things like offering unclear sort of options, like ROC can be supplemental, ROC can be optional, or some feature can be optional. But then we say ROC requires certain stuff to happen, which just create confusion. So we'll all cut those texts out. And then there is like wording of, oh, the underlying network may introduce more reordering, and that may be interpreted differently. Like we encourage to do more reordering. That's really not our intention. So we'll chop all this text just so that we don't create confusion. Thank you. Next slide. So that's my last slide, and I want to thank all the reviewers. It's not a complete list, but really we appreciate all these very thorough reviews, and we are going to do major search really on the text, hopefully soon, and then address all the comments individually from the on the emails. And if you have more comments, feel free to send us your comments, and that's it. Thank you.
Thank you very much. From the chair's perspective, I also would like to say thank you very much to all the reviewers. This will improve the document substantially. Any questions? Then I would say thank you, Yu-Chang, and we are looking forward to getting an updated document. Thank you very much. So this concludes the part of working group documents, and we are still over time. So if you can speed up your presentation, it's appreciated. The next one is Maj about a Yang model for TCP.
All right, thanks, Michael. All right, sorry for showing up as NetConf working group. I am here as an individual contributor, not representing the NetConf working group.
We know this problem.
The second thing is I'm not a TCP expert, and therefore for this presentation, I'm going to lean a little bit on my co-authors on the TCP portion. I'm more of a Yang person. And finally, this presentation is a combination of the updates to Dash 03 and 04 version of the draft. We had planned to, of course, present in 106, but ran out of time. And so this presentation is a combination of what we wanted to present in 106 and what we wanted to also present in 107. All right. With that, let's go to the next slide. So the updates in 3 and 4 include, of course, the fact that we now officially support the NMDA portion of a Yang, which essentially introduced 2 new data stores, the ones in blue, the intended and operational data store. This is more for informational purposes, not that it impacts significantly the model, other than the fact that all new models need to support it and that they don't need to replicate operational parameters in a separate container. The second update essentially refined the scope of what we wanted to include in the model. We wanted it to be more than just groupings, and the proposal was, and that we go into more detail in subsequent slides, is what we wanted to include as a result of that change. Next slide, please. All right, so coming into 106, what we were going to propose was that were 4 items that we wanted to refine the scope for this draft. The first one is, should the model support TCP statistics? The second, of course, is, should it model all TCP connections? And of course, the third and fourth is, what security options should be supported for TCP? So we took a stab and we actually went ahead and tried to added that support in 04, and I'll discuss the rationale for each one of them in subsequent slides. So next slide, please. All right, so the first question we asked is, should the model support statistics? The rationale for it is management is not just configuration, it's also monitoring, and therefore statistics play an important part of that. The next question obviously was what statistics we were going to support. So we took a look at what the MIB supports today for TCP. And we said, well, that's a good start for us. So we're going to support that to begin with. Next slide, please. The second question is, should we model all TCP connections? So if left to if we decided not to model TCP connections and the applications that needed to look up a TCP connection would then model it. Therefore, the modeling would get distributed in different models, other Yang models that wanted to look up TCP connections. So best thing was for us to consolidate it in one place. We have a precedence in the fact that the TCP MIB already models the TCP connections. And we took a cue from other Yang models that do this, particularly the BFT and the interfaces Yang model, both of which model either model all the BFT sessions or all the interfaces respectively. And finally, it allows for, of course, other models to be able to refer to this when they want to look up a particular TCP connection. Next slide, please. On the question of whether we should, of course, add support for TCP/AO, not only the rationale being that today the BGP Yang model actually relies on being able to configure TCP/AO. At least it plans to, it is already in the model. And since there is a requirement to secure BGP connections, obviously we would need that support. And I just list out the parameters that we want to model as part of that. The key and the keychain part for that configuration would, of course, come from the IETF keychain model that has already become an RFC. Next slide, please. So there was a little bit of controversy for why we wanted to support TCPM D5, but it ultimately comes down to what the market is asking for. And whether we like it or not, there are existing deployments of BGP that use MD5. And BGP has decided that because of that, they need that support from the TCP model. Next slide, please. So this is an issue that is new, and we are tracking this as part of the draft. Is today the TCP common grouping is, which of course defines the configuration for TCP keep-alives, is defined in another draft, which is being tracked in the NetConf working group. So it's an open question to this working group whether they would like to have it moved to this working group. The pros is, of course, that yes, the common grouping then becomes part of the Yang model. The downside is that today, NetConf is already made quite a bit of progress on that draft and is ready to close to publishing it. If we decide to move it into the TCP Yang model, of course, it'll cause a misref to all the existing NetConf drafts that reference it, but also delay, I guess, will put more pressure on publication of the TCP Yang model. All right, with that said, let's move quickly into, I think, what should be the last slide. Yeah. So why are we asking for workgroup adoption? Well, clearly there's a use case today. The BGP Yang model is already incorporated. The draft version of the Yang model, the TCP Yang model for authentication purposes. And also because the authors have believed that the model as it is being presented is fairly mature, or at least the work that should continue going forward should be happening in the work group. And therefore, we are asking for work group adoption. Questions?
Thank you very much. Yeah, the question was already raised on the mailing list. We got some feedback in favor of it. We got some feedback which suggests not to adopt it. Are there any positions from people which can quickly state it here now, or okay, so then that's the input we have, and we have to figure out if how we proceed with this. The decision, the chairs have not decided yet. We wanted to see if we get additional input here. Mirja is coming, and Martin. No, what? No, not Mirja, Martin.
Yeah, can the authors or anyone else articulate what the any TCP implementations are likely to use this to enable NetConf configuration?
So Michael, maybe my co-author, maybe he can try to see if he can answer the question.
Sorry, can you please repeat? I didn't fully get the question.
Yeah, sorry. Do we know of any TCP implementations that are interested in using NetConf to this Yang model and NetConf to configure themselves?
I mean, for this model, there are two use cases in the NetConf working group and in the other one. The NetConf model at the moment is independent, so this is where the keep alive exists. As far as I understand, there is commercial interest in configuring keep alive through a Yang model, but that is at the moment outside the specific model here. Other than that, at the moment, I'm not aware of any implementation who is doing this right now, but given that this relates to other working groups, of course, Yang implementation sooner or later could emerge. of course, I mean, I've said this many times on the mailing list, it's relatively unlikely that typical host operating systems will use Yang for TCP configuration. So this model, by and large, targets probably TCP stacks on devices that use Yang for configuration already for other purposes, such as routers.
Yeah.
If this answers the question.
Yeah, thanks. I had, I think, a similar question. I'm relatively neutral to this work because I think it doesn't hurt. But like if we adopt it, we have to make sure that the model is correct, and that needs a little bit of work. It needs a little bit of interest from people. It needs commitment for people to do the work. And I do have the feeling that we should rather try to finish up the work we already have on our plate before we adopt this as a new item.
Okay. Anything else?
Yeah, I'd like to speak as from the floor. So there's one thing that is not fully mentioned on the slide deck. So there is a question on the scope of the model. And for example, Lars, who has pushed back against adoption, is a little bit concerned about whether this work is doable, which is a reasonable comment. So the two options that the working group has is either to focus this model relatively narrowly and mostly to what Mahesh has presented right now. So these would be basically the model attributes that are needed in other working groups. The other solution is to significantly extend the model, for example, for standard TCP stack configuration. In past meetings, there has been from the floor asked for that, and I've tried to add this to the model to some extent, but that results in quite a bit of additions. For example, configuring ECN, turning on and off timestamps and the like. And so one question to the working group is if, for example, there are concerns about the complexity of the model if we narrow the scope to basically what Mahesh has presented right now, because this to me seems a lower hanging fruit, and the more complex general TCP configuration could be done in a follow-up work as well. So that's a question to the floor. If those who have asked for a relatively sophisticated configuration model, if they really insist in that being done in this specific draft.
I'm closing the line after Martin. Martin, you're up.
Just in response to that, speaking as an individual, I would encourage the working group to focus the work on no use cases. There are a couple of things here and there that are easy to add in, that's fine. But this is a potentially very large project. TCP configuration space is massive. And I don't want to spend a ton of cycles on stuff that has no deployment path. Thanks.
Thank you very much. We will discuss this and come to some conclusion. Okay, thank you. Next is Praveen on HiStart++. Be as quick as possible.
Hi, this is Praveen today to talk about HiStart++. We have posted a new draft version of this, version 3, recently incorporating some feedback. Next slide, please. This is a quick recap. So the problem is that traditional slow start can overshoot the ideal send rate, and this causes massive loss on the bottleneck buffer and then we spend several RTTs recovering from those losses. The goal is to reduce those losses and resulting retransmission timeouts that can cause problems in flow completion time. So this is based on the original HiStart paper, but we use only the delay increase algorithm, and we compensate for premature exit from slow start that can happen as a result of delay increase. For that, we start using a limited slow start, which provides us a faster ramp compared to what just congestion avoidance would have done. but we take the maximum of both so that on long, WAN links, we can get better performance if the connection runs longer. Next slide, please. So this is some performance data. I presented the lab data very quickly at the last IETF, but ran out of time. But we also got some production data as well. This is very recent. I got these numbers like 2 days back. This is basically every connection on a Windows system. We were doing an A/B test. This includes connections that are primarily download as well, which is why 99% of connections actually have very few RTOs. But we still see the graph shift to the left, so we have fewer RTOs. So about 0.64 connections went from 1 RTO to 0 RTOs over lifetime, and 0.7% connections went from 2 RTOs to 1 RTO. The trend continues. So we are also looking at other metrics, possibly like success percentage of loss recovery, etc. This is pretty difficult to do in the wild because it's not like one workload. It's not a single workload. It's basically just all TCP connections period. So this is ongoing work, and we'll have more data over time. We also have lab data, which actually shows very excellent results. So this is just with simulating loss and latency on basically trying to simulate WAN links and seeing performance improvements for in both good put, and we're also seeing a lot of retransmission timeout reductions across all the tests. Next slide, please. So we already had a few reviews, thanks to all the reviewers. So summary of changes, we had to clarify the relationship with ABC. The draft was sort of assuming that, but we didn't call it out. Yeah. So we actually have now incorporated text saying that this is to be used with appropriate byte counting. We also clarified when exactly the algorithm ends, which is upon encountering the first congestion signal. Fix the equations where there was some confusion between using a particular variable that was in bytes versus segments. And we also clarified some of the variable names, made them better. I think they were misleadingly, for example, referring to the slow start threshold. Next slide, please. So this is deployed pretty widely. We are looking into future optimizations, like maybe using bandwidth or throughput estimate to make this better instead of just using a delay signal. That's ongoing work. And then future, we would like to compare all the possible options for startup and do some sort of A/B testing to see what kind of results we can get from that. And then my request would be that we adopt this document in TCPM. That's all.
Can I just Sorry.
I'm not sure if I lost audio or not. Can people hear me?
Yes. I unmuted myself and I just got to speak now, if that's okay. So on the slide you say there is a 39% performance improvement for short flows and 40% for long flows. So that's basically because you have less RTO reductions, right?
Correct. So what ends up happening is that there is less loss, right? So we spend fewer RTTs actually spending time recovering from those losses, and also the congestion window. For example, like if we took an RTO, if the loss was massive, then we would actually take a retransmission timeout, which would basically drop the congestion window down to like 1 packet. So we avoid all sorts of problems by not overshooting the rate.
So, but those where you don't have an additional RTO or whatever, I think there is like a little tiny chance that it takes actually longer for the transmission to like tiny bit longer to compete, right? Is that the case, or is there no drawbacks at all?
So yeah, we basically avoid those losses. So that's why the flows complete sooner. So the overshooting is actually a bigger problem than being conservative.
So you have
more
cases where it takes longer.
As far as we observed in none of the tests, we had worse performance.
Okay. And by performance, you basically mean time to finish.
Yeah, flow completion time, correct.
Okay, thanks.
Martin. Turn on your audio.
I think Richard is next.
Yeah, I got Richard. Richard? Martin?
Yeah, this is all right. I'm very confused about the queue, but thank you for this, for your work on this. Can you say what you're thinking behind making this an informational draft rather than something with experimental or proposed standard for us?
I actually don't mind it being like experimental. The reason it is informational is we wanted to document our implementation and encourage more adoption and more experimentation. But I'd be open to changing the document type.
Last chance for Richard.
Is my mic now open? 10, 9. Hello?
Yeah. Yes. Hello.
Okay. I like this work very much because I also perceive buffer overshoot as the most significant problem that we are facing in our environments. So I would like to have this adopted as a working group item eventually.
Okay. Yoshi? Closing the mic after Martin. Yoshi.
I'm first. I'm okay.
Yes.
Okay. Okay. So one thing, if it's informational and you don't have to reflect the comment, because it's just what Microsoft is doing. But if you, change the status for experiment, you might seriously need to think about incorporate the comments from the people's idea. If they suggest to change the logic, you have to seriously think about the change the logic.
Okay, Martin, again.
Yeah, sorry to break it up into multiple comments, but I do support adopting this work. If there are other people interested in implementing this, then I would encourage us moving from informational to some other state. And I certainly sense interest in this. I can't speak to whether or not anyone plans to implement it. That maybe we don't need to resolve that today, but I would like to get some feedback on that. And if there are people interested in implementing, I think we should choose a more aggressive state. Unfortunately, if we choose to go standard, then we could do something about the status of ABC, which is experimental. But I think we can overcome that if that's the right thing to do.
Okay, thank you. So from the floor, I get positive feedback on adoption, on the adoption question. So we will discuss this between the JIS and go to the mailing list. Okay, thank you, Praveen. The next is a presentation about egg handling for wireless transports. And we are very short on time, so if you can get it done in 10 minutes instead of 20, that would be really great.
Hello. 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 Okay. So this talk is about reducing the acknowledgement overhead for the transports. Most of the work that we had done was in context to was not in context to the TCP, but on a UDP-based transport. But some of the observations that we got, we thought we might be able to port it to TCP as well. So next slide, please. So in the context of wireless, the cost of frame transmission is significant regardless of its size. So the interference spacing it causes most of the overhead, and even though the packet size is small, it still has a major impact on the control overhead as well as on the wireless spectrum. So this problem is further exacerbated because of the newer Wi-Fi specifications, especially like 802.11 AC and Wi-Fi 6, which has much faster fire rates, and it sort of accentuates the problem. Next slide, please. So, I mean, our scenario was very straightforward, so it did not involve the end-to-end path was a single hop. We tried solving the problem for a specific scenario where we have a phone and we were doing a wireless projection to a television, or most of the transfers were for the local transfer. So what we found that TCP was resulting in a lot of back overhead, and this was degrading the overall output of the link. We thought whether it would be possible for us to improvise existing TCP, and we tried to check what the knobs are, and we couldn't find any. I mean, we could find some of those, but it didn't give us the kind of expected ACK reduction that we were hoping for, and that's where we decided to do something about it. Next slide, please. So ACK. There are just two ways of reducing the ACK. One is by byte counting ACK, or ABC, and the other is the periodic ACK. So essentially, what our proposal is the combination of these two, and how in what context to be made use of, which one to make use of in what context. That is basically the fundamental point here. There's another aspect where there is a loss, in which case, just like Quick does, Quick requires you to just transmit the ACK as soon as you receive an out-of-order packet, so we handle it that way. But essentially, if the things are normal, if there is less loss rate, then it's essentially the choosing between byte counting ACK versus the periodic ACK. Next slide, please. So this is what we attempted. So if the BDP is small, eventually the byte counting ACK gets used. And if the BDP is large, eventually the periodical ACK gets used. So what happened is with near wireless standards, the BDP is significantly increasing. And if the BDP is increasing, then naturally it results in more amount of ACKs getting generated. We wanted to limit this ACK by making use of periodical ACK rather than sending ACK on every based on byte counting ACK. The next point is triggering ACKs for an out-of-order data reception. This is a well-known. This is how it is handled in Quick already. So we followed the same mechanism. Next one, please. So this diagram shows you how much of a reduction in terms of ACK were we able to achieve. If you see in the context of 802.11b, the performance was almost similar to TCP. It couldn't reduce much, but when it comes to 802.11 AC and the wireless interfaces which has higher data rates, we can clearly see that there is a big reduction in the number of acknowledgements. The difference here, so here, if you see, you don't see much of a reduction in context of 802.11b on the graph, but the numbers alongside will show you the reduction. Next slide. The good put improvements. So this is the graph on the left-hand side shows the good put improvement. This is the difference between the TAC versus the TCP. So what it shows essentially is accurate. It has a good impact on the overall good put of the TCP or of the overall transport. So on the right-hand side, what we see here is eventually the TAC eventually reaches the good put, the best good put efficiency at L is equal to 2, as TCP requires almost L is equal to 16. Theoretically, L is equal to 16. So reducing the acknowledgement has a direct impact on the good put. And next slide, please. So, I mean, I don't need to go into the details of this. Of course, when we are saying that we are reducing the acknowledgement, it has its own repercussions. It's going to increase the traffic burst. Eventually, what we want to say is there are specific connections which can benefit from ACK reductions, and some of the assumptions that TCP makes in context to making it generalized scheme may not necessarily be true in certain scenarios. Basically, enforcing some of the conditions which TCP mandates for all the connections may not necessarily be productive in all the situations, is what we are trying to say. Next slide, please. So one question that naturally arises is, what is the lower bound for ACKs, which is possible? So there is a seminal work in SIGCOMM basically which says that a minimum of 2 ACKs are required per cent window. So ideally, in ideal condition, that should work. That might work without much impacting the transport performance. That 4 ACKs is which suffices to maintain the performance. But having said that, 4 ACKs by itself still results in other problems. So just using 4 ACKs per cent window might not be good enough. That's where the formula that I mentioned previously comes into picture. Next slide, please. So some of the side effects the side effects of the ACK thinning are widely documented. It has impact on loss recovery. It has impact on traffic burstiness. In fact, the bursts are significant. One of the side effects that we saw was if the burst increases, eventually it results in much better Wi-Fi aggregation at the lower level. That's a side effect. Having said that, I understand that this is not a generalized statement. It has a positive impact in a particular context. But what it means is it still has a positive impact in at least in some context. After which it is possible for us to set connection-specific parameters to handle such kind of scenarios. Another problem that we faced was the RTT estimation. So naturally, with fewer number of ACKs, the RTT estimation will have an impact. RTT minimum RTT estimation will have an impact, especially under the conditions where there is high jitter. The distance between the two devices increases. It has a much bigger impact. There was something that we experimented with. We're making use of one-way delay and then approximating it towards the RTT main. While it works in near symmetric cases, it might not work in asymmetric cases. So it's not a generalized. It's a specialized solution for a specific problem statement that we are trying to solve. Next slide, please. So there is already existing work in the IETF that's happening. Wanted to compare it with what's happening. Maybe this part we can just skip over. It's already there on the mailing list. So what do we bring to the working group? So we wanted to bring our data set to the working group, saying that there are certain assumptions which may not make sense in specific scenarios, where there are certain techniques which can be used, which can improvise on the estimation of RTT mean, for example. There are certain techniques which could be used to reduce the burstiness of traffic. Of course, pacing can be used, and pacing has other implications if used in context to wireless scenarios. But ideally, what we're saying is it should be possible to tune the TCP parameters or the transport parameters on per connection basis and take it from there. I think we have a question on the mic. Yeah.
So yeah, I'm happy to let you finish, but if you're finished, I actually came in just saying, wanting to say, we have to be very careful that we don't aim for speed over latency, but I guess that's obvious. I guess the other point I wanted to make was that, can you go back to the previous slide, was it? I think, I can't, I don't know whether it was previous or the one before. Anyway, sorry, I've forgotten what I was going to say. Forget it.
So then may I jump in front of the queue here because Bob was jumping in front of me. First, I'm observed that you have missed XCC in your list of previous work. So that's basically the explicit way that a sender can ask a receiver to thin out the acknowledgements. So maybe a good idea to look at this as well. And also, basically, in conjunction with what Bob already said, it appears to me that you're looking primarily into web type traffic where objects get forwarded in one direction only. But I would be very interested what the implications here would be for transactional data, where the sender's role very, very frequently change between both ends of the TCP connections.
Right. Yeah. So this has to be generalized. So there is some observations we have in context to what happens if there is periodic app limited data in both the sites, and how do we handle it? I think this is something that we would like to update in the near future.
Thank you, Praveen.
Yeah. So current TCP stacks, my understanding is already do stretch hacking. That can be because packets get batched, or it could be because of things like LRO, where packets get coalesced in hardware or in software. So there's already stretch hacking being done by most major TCP implementations. So in your practice, in your data, are you really seeing an hack every 2 packets? That would be slightly surprising to me.
No, not hack every 2 packets, but still the hack reduction even after the underlying is not to an extent where it actually has. So we see that it is possible to further reduce the overall hack quantity. So there is Wi-Fi aggregation also down the line, which will result in coalescing of packets. But the impact that it has. So what happens is, what we found is, if the transport layer is not in control of this reduction while some other layer is doing it, and it has a much negative impact on the overall behavior, then so this is something that I think we should have put more objectively in the draft. Yeah.
Thank you, Gauri. And I'm closing the line after Gauri. Gauri, if you are saying something right now, you are muted.
Yep. Thank you. I like this work. I'm interested in this space. We did a lot of work with Quick, and in doing that, we noticed that Quick was a lot better for doing this than TCP was, because they had picked up things. So I'm interested in how you do all the corner cases. I think we might need quite a lot of data for different paths and different uses. So maybe we need to find a way of bringing different people together on this one.
Great, thank you.
Thank you. This brings us to the last presentation. Charts, also about acknowledgements in TCP.
Okay, hello everyone. My name is Carlos Gomez, and I'm going to present the document entitled Sender Control Related Acts in TCP, Problem Statement, Requirements, and Analysis of Potential Solutions. Next, please. Well, due to lack of time, perhaps it's better to skip the status slide. So next, please. Okay, so delayed acts is a mechanism intended to reduce protocol overhead. However, in some cases, delayed act may also be detrimental to performance. For example, when a segment carries a message of up to 1 MSS and the message does not elicit an application layer response, and a second data segment is not sent earlier than the delayed act timer, then the result is the act gets necessarily delayed, which entails a number of negative consequences. And Also, a sender may want to override or restore use of delayed acts at the receiver. So in this document, we summarize, we present issues due to delayed acts. We derive a number of requirements for a potential solution. And in addition, currently in the body of the document, we have a section on analysis of potential solutions based on the requirements. Next, please. About the issues due to delayed acts, we have identified issues in 4 main areas. The first is slow start, where congestion window grows by up to 1 sender MSS per every act that covers new data. The result is the delayed acts reduces number of acts received by the sender, then reducing the rate of congestion window growth, and therefore increasing transfer time, decreasing throughput. ABC might be a solution to this. It's already supported in several implementations. However, as mentioned before, well, it's not yet, not fully included in RFC 5681, which is experimental. And on the other hand, delayed acts also precludes sender behaviors for fast, non-intrusive capacity probing, such as chirping. Then the second area of issues is that of high bit rate environments and short segments are used. For example, a sender that uses NAGLE may be prevented from sending more data while waiting a delayed act, leading to high underperformance, as reported, for example, in the DNS stateful operations RFC, since in those environments, the RTT may be several orders of magnitude below the delayed act timer. Next, please. A third area of issues is IoT, where TCP is increasingly being used. Many IoT devices are significantly resource constrained, so a sender may not be able to release memory resources until the corresponding packet arrives. And this may be an issue for very constrained devices, eventually leading even up to packet drops. Also, many IoT devices are wireless and run on simple batteries, so a sender may need to stay with a radio interface enabled, which consumes energy until the corresponding act arrives. So if there's some delay with the act, then this may lead to increased energy consumption, decreased lifetime for the device. And also a delay might be exacerbated due to some negative interactions between the acts and some mechanisms available in some layer 2 technologies intended to save energy. Finally, a fourth area of issues is that we might want to enable act transmission behaviors beyond the traditional ones. For example, there's congestion control for acts in RFC 5690. And also there's scenarios with path asymmetric capacity, where the act arrival rate limits forward path performance. And in some technologies, such as DOCSIS mobile, cellular, and others, this is kind of mitigated by applying act thinning, but then this is out of the control of the TCP endpoints. Next, please. So we have derived a number of requirements for a potential solution to control delayed acts. The first is that the sender, the mechanism should be sender triggered or controlled, because the assumption is the sender knows when delayed acts should be overridden. Then we understand that the mechanism should work at a per segment granularity, as even within a connection, perhaps there's fixed traffic, and for part of it, the acts work as intended, and for the rest, maybe not. Also, the new mechanism should minimize header or message overhead, and it should also have support to enable generic ratios. Next, please. Also, the new mechanism should have as good middle box traversal properties as possible, and it should allow a safe return to normal delayed acts operation. Also, it should minimize impact on existing or future TCP functionality. And we understand we should avoid hacks, which may be suboptimal and have performance issues. And also, we may want to consider who's in control, since the receiver maybe cannot honor the behavior desired by the sender, and then there's a range of possibilities of what can happen at that moment. So next, please. Well, we have also collected a number of potential solutions that have been suggested since we started working on this space. So the first is ACC, where the sender tells the receiver which is the ACK ratio to be used. Axis C uses two new TCP options for that, and well, we may want to maybe take into account which is the impact of the overhead of that, and also middle box traversal of new TCP options is often regarded as bad. Then another solution that was suggested is TLP, where additional acts are triggered by sending a segment after probe timeout. This may entail significant overhead. Also, there's our earlier ACPUL flag proposal, which incurs no overhead but uses reserved TCP header bits. Next, please. Another approach could be defining a new ACPUL option, having similar semantics as the ACPUL flag. Also, another approach would be reusing existing TCP header fields. However, then the problem is that semantics may become overloaded. And finally, well, there are hacks which entail some performance issues and also cleanliness issues. So next, please. Well, we have summarized the solutions and whether they satisfactorily address the requirements. And well, the main conclusion is that no ideal solution appears to exist at the moment. There's a number of trade-offs. So next, please. Well, we'd like to thank everyone who has given lots of feedback all this time. And also, we would like to ask the working group whether the document would be ready for working group adoption.
Thank you very much. If you are considering your document, what would be the intended status of that document?
Well, I understand. Well, this would be informational.
Information. Okay. There were questions. Gori.
Oh, thank you for another talk about acts. Also interesting. Have you looked at RFC 7053 and the back pressure that was applied for doing the SCTP version of ACPUL?
I haven't yet looked at the document, so well, we'll definitely look at it.
Okay. So well, I'm saying that because when that was put up, I was very much opposed to it, and there was one or two reasons why that document made a good RFC. The list of issues I saw in the first issues list, I don't believe you. I don't believe that these are real issues. I'd like to discuss those on the list. Because things vary, this is something I think that is dangerous to pursue, and I think we need to talk much more about it before we consider working group adoption.
Okay, so thanks, and yeah, we'll bring this to further discussion to show which, well, to what extent these are issues.
Bob, if you are saying something right now, you're muted.
That's a good point. It helps, doesn't it? It was me that originally suggested to Carlos that he turns his proposal for the ACPUL thing into a requirements document on the basis that so many people were saying, oh, I like this mechanism, I prefer this one. And it was, no, I prefer this one. What about this one? I thought, well, you know, we're never going to get through this. Why don't we do what Carlos has started to do here? So I hope people like the approach of trying to pull together everyone's ideas as to what we're trying to do before we try and solve the problem. And that's what I particularly would like adopted by the working group, if you like. Whether this draft itself is ready for adoption, I personally think it's a good start, but I would you know, agree that the discussion needs to go on in the working group as to what actually goes into this draft. But I think there's so much pressure to do this that we need an exercise to sort it out. That's all.
I think. Okay. Any comments from someone else?
I agree there is a lot of need to be done on the acts, but I think I also want to second Gori that, you know, we need to, you know, there are like two drafts on this, right? And they are somewhat don't completely complement each other. So we should step back, look at the drafts in detail, and then discuss before we rush to adoption.
So this is Richard. One last comment. We have had the experience that that this problem of delayed acts under certain circumstances really is a major latency issue, and so I'm more in the camp of having the ability to do something about this would be good. So I'm not saying that that one or the other solution is better or proper, but I think we need to have the discussion.
Michael Tritson, as an individual, I agree. We need the discussion on the mailing list. We have 2 minutes over time already. But for Richard, if you say you have experienced this, it would be really great if you could provide some information about the scenario, the setup, or whatever you are experiencing this. Yeah, that's what Scory is asking. What is Richard's use case? So Richard, are you going to answer that?
Yes, but on list.
Okay. Okay, so this means with 3 minutes over time, we are done. Thank you, Charles. Thank you all for thank you to all presenters and the people attending. If you have anything to bring up, the chance is now. Going once, going twice. Then I would say, normally I would say, see you in whatever, but I'm not sure. So that's why, see you sometimes. Goodbye.
Thank you.
Thank you.
And thank you to Richard for taking the notes. Michael and Yoshi, can you stay?
Yeah, I'm here. Maybe I stop the recording right now.
Yes, you can stop the recording.